Good morning, let's have a class. And today we will move on to numeration of bacteria. So we'll do a spread plating. And Leon is going to get fact sheets, so you'll have that real quick. So let's talk about what is spread plating and how we're going to do it. Especially we're going to talk about C-area dilution. Okay, so this is Lab 7, I would say it's called spread plating. So this is very quick, we do a review. We had streak plating. This is what we already did, and we already talked in the lecture. This is testing presence, absence of bacteria on agars. And basically we could get is a single colony represents a pure culture. However, using streak plating, we don't know the number. So it's not called numeration. Now numeration, which means we know the exact number what it is. So there's basically two methods is spread plating, what we will do today, and pour plating. We'll do next week Tuesday, because Thursday we have a lecture exam, we just canceled the lab. Okay, want you focus on the lecture exam. Next Tuesday we're going to do this. Okay, so this is something we want to say. Now, this is the first one. Second, where this comes about the spread plating, how they generate. So very simple. This is a bacteria. Let's say E. coli. We grow at 35 degrees Celsius, 24 hours. In a liquid media, let's say nutrient broth. And looks very density. You can see it looks like this. It's completely turbidity, lots of bacteria. So we want to know how many there. So what we have to do, we need to be spread onto an agar plates. And once it's spread onto the agar plates, you will see these dots, which represents a single colony, and this means a single colony forming unit, and we call it CFU acronym. Okay, now there is a problem. What is the problem? This one is very density. How many bacteria here? And we talk about in the lecture the generation time, and the E. coli, the generation time is very short. It's only 10 to 20 minutes. And we talk about mycobacterial tuberculosis is very long, like 12, 24 hours. So bacteria during their log phase time, they're going to grow dramatically. So how many are there? It's estimated at least 10 to the power of 8, at least, even more than that, CFU per ml. Or we say cells per ml. So that's a lot. Now, this huge, if we are adding 0.1 ml onto the agar plates, which means 100 microliter onto the agar plates, it will be a mess. What you will see is completely like that, like a huge mess. You will not see any single colony because it's too many, it's too density. So what we have to do, we have to do 10-fold or 100-fold C-area dilution. And this is exactly the same what you did in your biology lab or chemistry lab. Okay, So what is tenfold serial dilution? We are going to prepare 3 tubes, let's just say 3 tubes. And every tube, we call it a dilution tube. We prepare 0.1% Mb neutron broth. 0.1% neutron broth, the osmotic balance is exactly fit the bacteria to grow and to survive. So there is something why we're not using tap water. Because tap water will cause anosmotic balance. The bacteria could be burst. We want to keep bacteria the balance, so we're using 0.1% neutron broth. Now what means tenfold serial dilution? We are preparing each of these tubes 9.0 ml. Okay, 9.0 ml. So what we do, we're going to add 1.0 ml onto the first tube. And then we mix very well. And then we add 1.0 ml onto the second tube. We mix very well. Then we're going to add 1.0 ml go to the last tube. Now what is the dilution factor? The first one is 10 to the 1, the dilution factor. Second one, 10 to the 2. And then the last one is 10 to the 3. Now be careful. We finish this dilution. This is the dilution factor of tube. Because when we add on to the agar, we are adding 0.1 ml equals 100 microliter onto the agar plates. So what is the final dilution factor of the agar plates? It will be 10 times more than that. So what's the final dilution factor of the plate? This will be 10 to the 2, this will be 10 to the 3, and this will be 10 to the 4. Okay? This is the final dilution factor on the agar. So that's called a tenfold serial dilution. Now, if we are using tenfold serial dilution for this tube, do you think it's enough? No. Because the last one, we're going to get 10,000 cells. It's still too much. And remember in the lecture, what is the acceptable zone? Is 30 to 300. This is acceptable zone. So, in today's class, we'll make your life easy. We're going to do 100-fold serial dilution. Okay. So what we do today is 100-fold serial dilution. So how to do today? Everybody will get a tube. Okay? This is E. coli. 35 degrees Celsius, 24 hours in neutron broth. This is right here. What's the first thing? Shake. Because we learned about 3 markers of the bacterial growth: the precipitation, the cloudy turbidity, and the pellicus. This looks like very cloudy and some precipitation. Make sure you shake it very well. Okay, the first thing you're going to have to shake. Let's do 30 seconds. Okay, then what we're going to do? We're going to prepare the dilution tube. The dilution tube is right here. The dilution tube is right here. You're going to get 3 dilution tube. Okay? So you're going to get 3 dilution tube. Each of these dilution tube is 9.9 ml. So what we're going to do? We're going to add 0.1 ml equals 100 microliter into the first tube. How are we going to do it? Pipette guns and the pipettes. And I hope everybody knows how to do this, okay, in your biology lab or your chemistry lab. Okay, so we're going to add it there. We mix very well. Then this have to be shake. We do 15 seconds and go here, also 0.1 ml, and mix very well. Shake 15 seconds and then go last one. Mix very well. Also 0.1 ml, shake 50 seconds. So, what is the dilution factor of the tube? Very easy math. The first one, 10 to the 2, 10 to the 4, 10 to the power of 6. Same thing. We are adding 0.1 ml equals 100 microliter onto the agar plates. So, what is the final dilution factor? On agars, it will be 10 times more than that. So, 10 to the power of 3. Go here, 10 to the power of 5. Go here, 10 to the power of 7. That should be good, because this will give you maybe 10 cells. This gives you somehow a couple of 100 cells. This is my one, you may not use it, but just in case we prepare. Okay, what we are missing? If you only write 10 to the power of 3, 5, 7, how do you know this is the tube is yours? So the same thing. You bench number, initial bench number, date, and what else? Bacteria name. Okay? Every single of them. Where you should label? At the back and on the edge. Because we need to count the colony. You write right in the middle, you cannot see it. So make sure on the side you write very well this information. Everybody gets 3 plates. The first thing is label them and label the tube. Always remember the tube dilution will be 10 times less than the final dilution factor of the plates. Okay? Here is one more thing we want to talk about that. So we are going to using 100 microliter tips. Once we do this serial dilution, change tips on each tube. This is very important because otherwise you will cause cross-contamination. Make sure you change your tips all the time. Okay, then what we do? Once we finish everything here, we're going to add them onto the agar plates. You always add from highest to lowest dilution. Only need one tip. Is go this direction. Okay? So you have a tip go here, tip go here, and tip go here. The reason is, although the bacteria could carry from 10 to the power of 7 to the 10 to the power of 5 and to the 3, but the carrying amount will be very minimal. You know the math, is that right? You already diluted the 10 to the power of 7. And then you said, yeah, I'm carrying a little bit to go to the second place. It doesn't matter, it's not going to show up. But when you go, you cannot go this way. When you go this way, you have to switch the tips, because otherwise you will have a huge number of cross-contamination. Okay, the last thing is the spreader. So spreader, we are using plastic spreader like this. It's already been pre-sterilized. Once you have spreader, spread here, and go here. Also, from high to lowest dilution. Only need one spread. That's all. And finally, all these three plates, we need to do incubate 35 degrees Celsius, 20 to 48 hours. We could just put them in the room temperature because you're going to see them on next week, Tuesday. Then we can count the colony. Okay? Same as before. We want everybody go to the bench there, and I'm going to be showing you how to do the spread plating. It is a very important technique. It is used widely in the lab. So I do want everybody to learn how to do spread plating. Okay? It's quick, not difficult at all, but you have to be careful. There's a lot of tricks there, I have to say. Because we were doing this in the lab for me, close to 20 years, and some of you the first time to do, there is something have to be careful. Okay, so make sure that lots of the material you have to be ready. What we're missing here is a pipette tips. That's some of them from my own lab. You have tips, bacterial dilution tube, and also you have the spreader. First thing first, these agar plates is coming from the refrigerator. Very wet. You're the first lab in the morning. Very wet. What you should do, use paper towel to dry. Dry outside first. Okay, otherwise you cannot label. So dry outside first at least. Second, look at the inside. This is we call it a condenser. Like what we talk about the capillary water. Okay, make sure inside you also cleaned it. Otherwise it will bother the results. The second and third last lab, it doesn't matter because it's going to be in the room temperature a little bit. Look at these density. It's going to bother you. Okay, so make sure these are dried out. Now we're going to have to do the label. What are we going to do the label? 3 plates. This is the first one. We write 10 to the power of 3, 10 to the power of 5, 10 to the power of 7. Now you write your initial, bench number, E. coli, and date. What the date today? 17 or 16? 17. Okay, 17. CS. That's my initial, bacterial name, date, initial, bench number, bacterial name, and date. Okay? This is ready. Like that. Okay, now here, make sure they are arranged very well. You go this direction, that direction, that direction. Okay, now we need a Bunsen burner to turn on. So then, this one. Oh gosh, this is horrible. Can't use the other one, I'll just use this one instead. Oh, this is very long. Look at this. It's super long. Hold on. We'll just do it. Be careful about that iPad. Okay, that's fine. Okay, now let's do it. What we do. Tips, all these things are ready. Okay, this is autoclaved, so we know it's already been autoclaved and sterilized. Okay, first thing first. Shake 30 seconds. Okay. Because it's look at lots of at the bottom. Shake 30 seconds. shake. Second thing what we do is have a tips. Make sure it's at 100. That's important. Some people don't even see it and just get it. That's wrong. Now how we do? Little finger, flame, get 100 microliter. Flame, put on the side. Okay, first one. Flame, add in. Flame again. This tip needs to be changed. We don't have vortex, shake 15 seconds at least. Okay, put on the side. So that means it's ready. Next one, flame at 100 microliter. Flame again because you're going to use it. Okay, go here. Flame again. This needs to change. Okay, this kind of loosen. Be very careful. Shake 15 seconds. Okay. So the next one, flame, flame again. The last two, flame, add, flame again. Now shake 15 seconds. Okay, everything's ready. These are in the order. We're going to add into the agar plates, and they said only one tips from high to lowest dilution. Get from here. Flame, 100 microliter. Do we need to change? No. Because we're from high to low. Okay, last one. Go here, then. Okay, everything's ready. Spread the plating. This is a sterilized plastic spreader. You can flame it. It's gonna melt it. Okay, that's common sense. So what we do, directly use it. Go here, the first one, spreader, like that. Okay, averagely cover the surface. Do not damage it. Okay, the first time you do, lots of you are using hard force. Oh, it's a much power there. You don't have to do. Average spread on the surface. Second one, like that. Okay. Third one, like this. Spread them very well. Then stack it. Make sure this is turned off. And don't go immediately. Wait about 3 to 5 minutes. Because when you give to TA, flip it over. Why? Otherwise, this moisture in the 35 degrees Celsius incubator, they'll cause condenser. Then the liquid will be damaged the agar. You will see a huge smear. Instead of you see those colony. Flip it over to give it to TA. And he will do an incubate for you. Okay, so today's work is simple. Bacteria string is in the front desk. Everybody go there to grab 1 fact sheets, 3 plates, 3 dilution tubes, and tips and spreader are shared by the whole bench. What you should bring? Not bare hands. Rack. Okay, everybody bring the rack because very easy to fall down. What the first thing you do when you get those? Label. Okay.